Hey everybody, this is Larry. This is me going Q2 of the weekly contest 492. Find the smallest balanced index. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So there is a catch on this one is that, the sum part, I hope, I talk about prefix sum a lot. So definitely, I hope your idea of the prefix sum. So that'll take up the sum part, the left part, right? But the right part is product, and you might be tempted to do a prefix product, right? Or suffix in this case, but the idea is still prefix, but just reversed, right? However, the thing is that because the numbers can be very big, you may, even though it might not be incorrect in certain languages, that may just be wrong, right? For whatever reason. And the two, because there are also edge cases that you might have to consider about, right? Yeah, but the biggest thing is that if you use Python, I'm going to talk Python for a second, is that it might time out, right? Just because you're using a big int, and then if you grow it unbound, then you may time out. And if you're using another language, you may wrap around, and I don't know if there are specific test cases in Leetcode to kind of catch it, but maybe there is, maybe there isn't, but they might do it if you're not careful with handling how you multiply numbers, because the numbers can get very big. You may overflow, so it's not big, so you may not time out, but you may get you may hit a false positive if they choose numbers in a way such that it collides, right? In any case, in theory, this is a easy problem, but that's how it can be tricky. The way that I handle it is that, well, on the left side, I still use a prefix sum, right? And on the suffix, I still use prefix sum with the product, but I bound it by the infinity, which for me is still, basically it's just a big enough, you just have to choose a number that's big enough, but impossible to match, right? And because you have 10 to the 9 on the left side, each number, you have up to 10 to the 5th of them, you have to choose a number that's bigger than 10 to the 14. That's basically the idea. You just have to be a little bit careful, because then this will just never be true when the suffix is too big, right? And that's it. This is going to be linear time, linear space. You can probably optimize that a little bit. Not in the big O, but you can just have only one array, for example, for sliding on the other or something like that. In fact, you could probably do 2 sliding if you're really careful. Oh, so you can do this in all one space if you're really, really careful. But of course, during a contest, I did this in about 2 minutes. I'm not going to optimize the space if it's not necessary. And that's it. That's all I have for this one. If you feel like it, upsolve it to do it in constant space. And yeah, thanks for watching. And you can watch me solve it live during the contest now. Man, I am bad. All right. Well, okay, so load this time at least. It's equal to, okay. There's a lot of numbers though. So 10 to the 9. Something is really weird with my setup, honestly. But maybe I just haven't done it in a while. I'm complaining. That's probably not right. Did I mess it up? Should match up. Or maybe it matches up. I don't know. 0, 4, 2, 2. That's weird, right? Oh, why did I return -1 on that one? Whoops. What a silly typo. 1 negative. That's what I thought. Or I thought this was a possibility. That's why I had to double check it. I got lucky on the examples. I had to check it out. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, this contest, everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.